So as we continue learning about the Hadoop ecosystem, another concept that we need to consider is a Java virtual machine. Now in the Hadoop world, Hadoop processes or execution activities run in separate JVMs. The concept of a JVM may be unfamiliar to you, so let me give a brief explanation. It's basically a process for executing Java bytecode in an executable program. So it's a little section of the program that runs. And in the world of Hadoop, it's really important because JVMs don't share state. Now, traditionally in database processing systems, state is shared. And this is a different programming paradigm that when we get into the internals of the processing around Hadoop, which is MapReduce, it will be really critically important to understand. JVMs do not share state, and the different Hadoop processes run in separate JVMs. Another consideration that we'll be covering in this course is that JVM process for Hadoop changes from Hadoop version 1.0 MapReduce, which we're going to start by covering because it's kind of the basics, to Hadoop 2.0. There are substantial changes in the JVM implementation for Hadoop from versions of 2.0 and forward. And as of this recording, Hadoop current release is 2.5. As we continue our exploration of the Hadoop ecosystem, let's look more closely at the file systems that can be associated with the Hadoop distribution. The default is to use HDFS, which we talked about in a previous movie, accounts for larger chunking of the data into 64K or 128K chunks, and is triple replicated by default. The HDFS file system has two modes for implementation. Fully distributed, which will give you the 3 copies, or pseudo-distributed, which will use the HDFS file system but is designed for testing. But it is designed for testing and will be implemented in a single node on a single machine. As an alternative to HDFS, you can run Hadoop with the regular file system. This is called the standalone mode. And it's a great way when you're just first learning about the MapReduce programming paradigm. You're reducing the complexity by just working with your regular file system. I'll be showing this in some of the demos in addition to showing HDFS. Alternatively, when you're deploying Hadoop to production, particularly if you're deploying on a public cloud, it's really common to use a file system that's on that cloud. For example, in Amazon, the S3 file system, or in Azure, the blob storage, which is similar to the standalone mode in that you are not using HDFS. You're using a regular file system, but using a cloud-based file system. Another consideration is to understand how the file system of choice for your Hadoop implementation and Java virtual machines interact. If you deploy Hadoop in single node, you're going to use the local file system and a single JVM for all the Hadoop processes. Now I know I haven't covered all the various processes yet, but we'll be going there shortly. If you deploy in pseudo-distributed mode, you're going to use HDFS, and the Java daemons are going to run all the processes on a single machine. If you run in fully distributed mode, you're going to use HDFS, it's going to be triple replicated, and the daemons are going to run in various locations depending on where you choose to place them. This placement choice is an important implementation detail in a production workload. To give us an idea of what this might look like, here is a drawing showing some of the common daemons and how they're distributed. So you can see in this particular drawing, we're in fully distributed mode. We have 3 separate physical servers. On each server, we have various daemons and they're represented in green. So you can see we've got task tracker on each one, and then we have a job tracker daemon that is actually implemented on a different physical server. In addition to that, we have some other daemons that control the data distribution, the name node and the data nodes. Again, it's important to remember that in a production situation, these are separate JVMs and they do not share state. So we've got a lot of background information about the Hadoop ecosystem, and it's time to take a look at it in its full glory. It's a little bit of a scary picture with all these boxes and components, and one of the aspects of working with Hadoop is understanding what's possible and picking the various components that are right for your particular business situation. So I'm going to take a couple minutes and go through the core components here And we'll be hearing about them again and again throughout the course because it's a little bit overwhelming when you first see it. So at the bottom you can see that we have HDFS, the Hadoop Distributed File System, which we just covered in terms of files. Most commonly used, but as I mentioned in the previous movie, sometimes the file system used, particularly in cloud implementations, is actually a more standard file system like Amazon S3 or Azure Blobs, depending on the cloud vendor. But it is common to use HDFS. Sitting on top of HDFS, the second core part of a Hadoop implementation is MapReduce. Now you'll see another new term sitting on top in this diagram, which is MapReduce version 2. This is also called YARN, and YARN stands for Yet Another Resource Navigator. And we'll be covering both MapReduce 1 and 2 in this course. It has become standard at the time of this recording that MapReduce 2 is more commonly used, but it does build on top of MapReduce 1, so it's a good way to learn the processing framework. You can see in addition to this on the right, we have HBase, which we covered in a previous movie, very commonly used to be able to query out of a column store abstraction over the top of the file system. And next to that is Hive, which is HQL, or the SQL-like query language that is used to query HBase. There are other libraries shown here as well, things like Pig, which is a scripting language that's used for ETL-like processes, or extract, transform, and load. You'll also see we have the Mahout library, which is for machine learning or predictive analytics. We have Uzi, which is for workflow or coordination of jobs. And that works in combination with Zookeeper, which is coordination of groups of jobs, and we'll see both of those things. Scoop is for data exchange in between other systems, particularly relational systems like SQL Server and Hadoop. Flume is a log collector because Hadoop jobs produce a large amount of log information about job process because the jobs are run in batch, so they take time to run. And in this particular diagram, we also have Mbari, which is provisioning, managing, and monitoring Hadoop clusters. This is a representation of some of the open source libraries in the Hadoop ecosystem. There are actually more. These are the core libraries. Now, to contrast this, we're going to take a look at a commercial distribution. You can see for Cloudera's commercial distribution, in the center is Hadoop, and that's assumed to be HDFS and MapReduce 2. Surrounding that is Pig and Hive. To the right, you see HBase. You see Hive up above HBase as well, because it's both for metadata and for query. You see something called Hue sitting on top of that, and that's specific to Cloudera. We're going to actually take a look at that coming up here in just a couple minutes, and it's a graphical user interface that makes interacting with Hadoop information simpler. You also then see Uzi, which is workflow and scheduling. You see Zookeeper for coordination, and Flume and Scoop. It is an important consideration when you're selecting a distribution to understand which libraries and which versions of which libraries are supported by that particular vendor, being able to match the capabilities of the libraries with your particular business needs. So we've been talking for a while about Hadoop concepts, and you're probably getting anxious to actually get started programming it. So how do you do that? There are a couple ways to get it, as I mentioned in previous movies. You can get the open source version here, and you see here's the main site, hadoop.apache.org, and you can actually download the latest version of the binaries and set up Hadoop on your own. It does take a substantial amount of time to download and set up plain vanilla Hadoop on a Linux box. So for the purposes of this course, we're going to use a virtual machine, which is a lot quicker to get started. But I wanted to show you where this site was. And before we leave the site, I want to tell you a little story about the yellow elephant. I actually had the good fortune to meet Doug Cutting in person, who is the primary developer of Hadoop. And he didn't tell me the story, but he tells the story. His young son was playing with a yellow elephant when he was translating the Google open source information about GFS and MapReduce into Hadoop. And his son called his little elephant Hdoop. And so in the beginning, there was quite a lot of discussion about, is it Hdoop or Hadoop? And it's just simpler to pronounce it the latter. So if you ever wonder where the little yellow elephant came from, it was Doug Cutting's son's toy. It's kind of fun to know about that. So anyway, so if you wanted to get the open source version, you'd go here, but we're really not going to do that. We're going to look at various vendor distributions because they're much easier to work with. So the one that we're going to start with is Cloudera. We're going to look at several of them. Now, to be clear, most of these vendors have a free version to try out, and then they sell an enhanced version. So when you're working with this, what you're going to want to look at is you're going to look at the products, and we'll look at the various vendors, and you can see, in the case of Cloudera, we have Cloudera Enterprise, which is something that you would pay for. I believe they have a trial version, but they also have Cloudera Express, and as we'll see in a minute, they have Cloudera Live. Cloudera Live is really a great thing to try out because it basically allows you to try some of the querying and the interaction with the data in a browser without having to deal with any setup, and it's a quick start tip. Most of the major vendors, Hortonworks now has it, and I believe MapR have an in-browser option, and it's a study tip for those of you that are working on the exercises in this class.